Okay. Okay, so 8.1, solving equations by graphing. I want to go through two different types of examples. Yes, they're the example from your book, but I don't want you to simply read out of your book because then that's not really serving any purpose. But okay, the first question. Karina wants to determine the area of a garden enclosed by 32 border tiles. The garden and border tiles are part of this pattern. So you can see the pattern right there, surrounding the single, surrounding 2, surrounding 3. So I redrew those right here. Now you're going to solve this using algebra. In the first picture, what do you notice? I have one green tile. What do I have that's consistent between the three pictures? Alejandro, let's go. I did funky colors because I actually like that pink color. I don't know why. Purpley, pinky color. What do you got? What are you seeing? Nothing?
Keep on adding more.
All right, so you got to try and find consistent things. Now you can do this a number of different ways. You can just simply say for every green I have 8 purple, pinky, whatever we're going to call that, and then you can simply draw a table, but we'll skip the table for right now. When you look at these three images, here you have one green. On the side of the green, you have how many on this side?
3.
And you have how many on this side?
3.
Now does that change at all? 3 there, and 3 there, and 3 there, and 3 there. That does not change at all throughout any of the images. So remember that, it's a constant. So here you have 1. What do you have on top and below? You have 1 green. On top of every 1 green you have 1 purple on top and 1 below, giving you 2 purple for every
Square.
1 green square. Garden square. So you have 1 and 2 for every 1. Does that work here? I have 1 here, I have 1, 2, and I have 1 here, I have 1, 2. All right, so now you're going to develop equations based on this. How many do I have on each side again?
3.
3 and 3. No matter what, I will always have 6. Right? So we're not beating around the bush. The question gives you the formula of 2n plus 6. So I get it, we can copy the formula out of the book, but how do we get the formula? The 6 we've got. What does the 6 count for?
Purple square on the side.
The purple squares that are constant on the sides. They're your borders.
Pardon me, Mr. Duggan.
Yeah,
Could Janisha come to the office for a moment?
sure.
You-
Okay, we're filming this, so don't ooh and ah. Okay. So, we've already figured out, so they're giving you an equation of 2n plus 6. If you get it, great. If you don't, let's figure out why. We figured out the 6 already. Now, how do you figure we get a 2n? What does the 2n count for? What does it stand for? Yeah. Sure, 2 times the term number, but give it to me in non-mathematical terms here. 2 times the term number, giving you the term value once you add 6 to it. Perfect. But what does that mean in this example? What's your n?
3.
Sure, it's the term, but what is it given the example? The example is talking to you about the green inside the purple border tiles. So the n is the number of green squares. What's the 2? Let's think about it this way. This is already covered because we have 3 and 3 giving us 6. Right? So if that's already covered, what's the 2 times the n part?
On top of the green and
On top and below. So I have 2 purples for every 1 green. Does that make sense? 2 purples for every 1 green? Yeah?
Yeah.
Sacco, does that make sense? Yeah? You wouldn't even know. What if I asked you a totally random question there? You just said it so quickly. But okay, so here our 6 are covered. And there's 2 here and 2 here, and there's 2 in here. So there's 2 for every green there, and okay, if here we have our 6 covered as well, Now there's 1, 2, 3, 4, 5, 6. For 3, it still works out. So I can ask you for a garden that contained 3,749 tiles of garden. You don't have to draw that out to figure out how many border tiles there are. But you're thinking about this in an opposite way. The question told you something else though. The question says, Karina wants to determine the area of a garden. The garden is enclosed by 32 border tiles. So as you can see her question here, you plug the next number in because actually this question is going to tell you, this equation is going to tell you how many border tiles there are. Right? So 2 top and bottoms for every green you have, plus the 6 to the sides will give you 32. So how do I solve this equation just using easy math here? Somebody solve this for me? Someone, how do I get n by itself? Subtract 6. So I move the 6 across. 32 minus 6 is going to equal 2n. So 2n equals, please don't make me do this all by myself. Okay, I did it all by myself. How do I get rid of the 2? I divide by 2 on both sides. So I get 26 divided by 2. N equals all right. So now tell me, how can we do this using a table? So take a look here. If I have 1 green, how many purple do I have? Everyone shout it out all together. You can all count. 8. Cool. If I have 2, how many do I have?
10.
Okay. If I have 3, how many do I have?
12.
Now, just taking a peek here, 8 for 1, 10 for 2, 12 for 3. How many do I have for 4?
16.
14. And for 5?
16.
16. And for 156? Come on, all together, really quick. For 156? So it gets a little bit more complicated. That's why it's easier to use an algebraic equation. Now, if you don't feel, so 2 different examples. You can look at the picture and develop the question. Julia, put your phone away. You can, okay, Kalan, put your phone away then. So you can look at the picture and determine the equation out of that. Or you can simply use a table to determine the same values. So this is something you should have learned last year as well. It's something they expect you to know walking in here. You use the gap in between these. So what is the gap here? 2 and 2 and 2 and 2. So you get your term number, which is n, which is going to be this column. So you use your term number here, and you multiply it by the gap. N times the gap.
Is 2.
And then you add whatever else you need to add. This should be a review to you. You add whatever else you need to add to get to the term value for the given term number. Meaning I know the gap is 2, 2, 2, 2, and I could assume, or I don't even have to assume, that the gap remains 2 all the way along. Right? So what you have here then is 1 times,
2.
okay, 1 times 2 is what?
1, 2.
2. So what do I have to add to 2 to make that 8?
4. I don't know.
2 plus 6 is 8. What did I just develop? The gap is 2 multiplied by my term number, and I had to add what to it again to make it 8?
6.
I just developed the exact same formula that we did based on the pictures. So again, if you're struggling with that idea here, all you do is multiply your term number by the gap number, and then add whatever or subtract whatever you need to do to get to this number. And that'll be your formula for everything. So then if I wanted to figure out what 156 would be, all I have to do is go 2 times 156 plus 6. What is that, 318? So I'd have 318 border tiles if my inner garden was 156 tiles. I really hope my math was right there. I think it is. Okay, I want to try one thing here, quick. So, what do you see here? How many do I have?
5,
5. How many here?
11, 12, I don't know.
Count. 8. How many here now? 11. Okay, so 5, 8, and 11. All right, Daniela Hernandez. So we counted this already. We have 5 there, we have 8 there, and we have 11 there. How many would be in my fourth picture? Can anyone help her out? 14. Now you're guessing at this, but you're seeing the pattern. There's 3 here, there's 3 here, there's 3 here. How many would be in my fifth one? 17. How many would be in my 752nd one? Good luck getting there if you don't use algebra.
3 times.
I don't have time to sit here and wait for you to figure it out because this video is already getting long as it goes. We're at 12 minutes here. So our pattern again then was to multiply our term number by the gap in between these numbers and then add or subtract whatever you need to do to make that number. So what's the gap in between 5 and 8? All throughout we have 3. So we multiply our term number by the gap and then add or subtract whatever we do to get to there, and that's going to give us our formula we could use for every single one of them. So what's 1 times 3? 3 times 1 equals 3. And what do I have to do to get to 5?
Plus 2.
I'm going to have to add 2. So 3 times whatever number you want plus 2 will give you how many squares are in whichever one you want to draw. So for 752, 3 times 752 plus 2 is going to equal 2100, 2256, 2258. Is that right? 2258. Did I do that right?
Yes.
Hey, okay. So that's how you could figure out how many squares would be in, so that's how you can develop 2 things. You can develop based on a picture. You can use a picture to determine, just like we did, that there are 6 on the sides and there are 2 for every 1 green. You can then take a table. Sydney, relax. You can then take a table, determine the gap in between every one, multiply the gap by a term number, and add or subtract to get to your term value. And either way you produce the equation from either the visual picture image or the chart image, you determine your algebraic equation and can figure out anything.
Don't forget to like, comment,